So let's talk about the equation of a straight line. This is what we call the general form, or as we'll see later on, gets also called the gradient intercept line intercept form. Okay, you'll see it's in the form of y equals mx plus c. Notice that x has y as its subject and then equal to mx plus c. So that's some coefficient in front of the x and c being just a number, a constant. Okay, so let's talk about this gradient. Now, I like to also call gradient the slope. Okay, that's a bit clearer, and it gets called slope in further maths or general maths. So the gradient or slope of a straight line. So when we think of a gradient or slope, we think of it relating to the steepness of the line. Now, steepness is something we may think about with a hill or a ramp. Now, when you think about a hill, a hill or a ramp, we think about how steep it is. Now, we know that that is steeper than that, isn't it? Now, why is that? Why do we consider this steeper than that? It all comes down to this change of vertical distance over the horizontal distance. So here, we're gone up quicker, haven't we? We're changing that vertical distance over a shorter horizontal distance compared to that one. And that's why we consider this one steeper than that one. Okay, so we call that vertical distance rise. You can see here drawn as a triangle, it's that rise. The vertical distance is the rise, it's rising up. And the horizontal distance is that run. The run there. Okay, so we end up with the idea that our gradient is rise over run. Now, I grabbed a few things from the textbook here to help us out. So we can see here that we've got a vertical distance of 2. Our rise is 2. Our run is 1. 2 divided by 1 is 2. So that's our gradient of 2. Here, I've got a rise for 6, a run of 3. 6 divided by 3 is 2. I'll look at this one now. So here, I've got a rise of 1. The vertical change of distance is 1. It's gone up 1. It's changed by 1. And the run, the horizontal change, is 2. So we get left with this gradient of 1 over 2. Now, with gradients, we tend to leave them as a fraction. Why do you think? We tend to leave it as a fraction because then we can clearly see that it's rising up by 1 for every 2 it runs. Okay, so for each, it goes up 1 for every 2 across. Here, well, if we're looking at this one, for every 1 unit it goes across, it rises up by 2. For every 3 it goes across, goes up by 6. And that's how we should be thinking about a slope. Now here, we've got a change of 2 over 1. But you're probably wondering, how come we have this negative here? Well, that's because we tend to read all of these slopes from left to right, okay? And so that is a slope going upwards. It's positive. It's going upwards from left to right. But here, from left to right, it's going down. It's going down. So we think about that 2 as a negative 2, that it's going down by 2. It's negative. It's going down by 2. So that's how we end up with a gradient of negative 2. Here we have a rise of negative 1. It's gone down by 1 over a run of 2. So that's how we end up with our gradient of negative 1 over 2. Now often we need to find the gradient of a line that's passing between 2 points. So we get given a graph, or we get given 2 points, and we have to find the gradient between them. So again, I've taken this from the book because it helps a bit with diagrams and things. So you can see here, I've got this coordinate point, which is 1, 4, and that coordinate point 3, 8. Okay, now we always tend to read these graphs in terms of going from left to right. Okay, from left to right. So reading it that way, I'm going to call that point 1, and that one point 2. Now you're probably wondering, but Miss, if we're not given the graph, how do I read it left to right? Because I tend to always put the one on the left as point 1 and the one on the right as point 2. How do you do that? Well, I always look to see which one has the lowest x value. The one with the lowest x value, I always call that point 1. Point 2, the one with the higher x value. Make that look clearer. Okay, so then I think about, all right, I want to figure out what this rise is and what this run is. How do I figure that out? I need to know how much it's gone up. So how much has it gone up? So I need to know the difference between the y value in point 2 and the y value in point 1. So that's 8 minus 4. Now to get our run, I need to know the difference between the x value in point 2 and the x value in point 1. You can see why I tend to put that higher x value as point 2. So we will get a positive x value down the bottom here. So that's 3 minus 1. So 8 minus 4 over 3 minus 1, we get 4 over 2. So that gives us a gradient of equal to 2. Now this is our formula for finding our gradient. This is our rise over run, but all in algebra. That's the y value of 0.2, take away the y value of 0.1, over the x value of 0.2, take away the x value of 0.1. So let's do some examples. So let's find the gradient of the line between 2 points. So our first one is 2, 8 and 6, 18. Okay, so that is 0.1, that is 0.2. So x1 is equal to 2, y2 is equal to 8. Now you don't need to do this every time. I'm just doing this the first time to help out everyone. So x2 is equal to 6 and y2 is equal to 18. I just noticed that little mistake I made there. Wonder if you did. Like that. Now I hope you noticed that when I was saying x2, that 2 went down the bottom. This is why I was so strict on you saying x squared, not x2. Okay? This is x squared, that's x2. They mean two very different things. Okay. So, m equals y2 minus y1 over x2 minus x1. M equals 18 minus 8 over 6 minus 2. So our gradient equals to 10 over 4. Okay, now I'll leave it as a fraction, but I'll simplify that to, that will be 5 over 2. Okay, so here I've got another set of points, -1, 7, and 4, -3. Now again, I'll look at these. Now that's the lowest, that's the lower x value. So I'll have that as my 0.1, 0.2. So m equals y2 minus y1 over x2 minus x1. M equals -3 minus 7 over 4 minus -1. So m equals -3 minus 7, that gives you -10 over -4 minus -1. Now you'll probably remember when you've got the two negatives like that, it's the same as a plus, so that's 4 plus 1. So that is 5. So m equals -10 divided by 5, which is -2. Now, sometimes we have a graph that looks like this. You can see here that our y value is constant at -6. It's unchanging. It doesn't matter what the x value is, the y value is always -6. So, what's the gradient of this graph? So, picking any 2 points in the line, I'll pick x equals -10 and x equals +10. And I'll substitute it into our gradient, which is m equals y2 minus y1 over x2 minus x1. So -5, take away -5. Oh, we'll put that as -5. That should be -6, shouldn't it? Well, same difference. So m equals -6, take away -6 over -10 minus 10. So that is -6 minus -6. So that's -6 plus 6 gives me 0. -10 minus 10 is -20. Now 0 divided by any number is 0. So the gradient here is 0. Okay, that gradient of that horizontal line is 0. Now here we have a vertical line, So the x value doesn't change, but the y values do. Okay, let's pick any 2 points on here to see what this gradient is. I'll have x equals -10, y equals -10 and y equals +10. X is equal to 7 the whole way. So we've got our 2 points of -10, 7. So that's 7 -10 and 7 +10. So subbing them into the rise over run, I've got -10 minus 10 over 7 minus 7. So I've got -20 over 0. Now, as you know, if you divide anything by 0, The answer isn't 0, it's actually undefined. Okay? We don't have a numerical value for it, so it is undefined. So if you have a vertical line there, the gradient is undefined. Now I've just cut and paste work example 6 here from the book. I just want to talk about it a little bit. So finding the gradient of the straight line from its rule. So this is where you're given an equation and you have to find the gradient straight from it. Now, that's because if it's in this general form, the gradient is the m value, the coefficient of x. So you can see here y equals negative 2x plus 3. The m is negative 2, the coefficient of x. Now, if it's not in that form, you have to transpose the formula to make y the subject, which is being done there. So you can see, okay, there the gradient is 3 over 2. So they've made y the subject in order to find that gradient. All right? So you have to be able to transpose these equations to make y the subject. Here, as we've just discussed, that's a horizontal line, so our gradient is equal to 0. Now the y-intercept. The y-intercept occurs where the line cuts or intercepts the y-axis, okay? And that actually is also shown in the general form of our equation. This is why we also call it the gradient intercept form. And it happens at C, where y equals to C, okay? So because at that point, you've got to imagine there, that's along the y-axis is where x is equal to 0. So if you sub x into 0, equal to 0 into that equation, you get that whole bit will be equal to 0, so y will be equal to c. Okay, so that will be there. So if you're asked to find the y-intercept of an equation, you just make sure it's rearranged into that form and the constant tells you what that intercept is.